There you go. All right. So we got a block. It's on a slope. If this is frictionless, what's going to happen? It'll slide. And if it doesn't slide, your name's not Clyde. No. It's got friction. Okay? And now depends what rate is this going to slide. Like, what is the friction? That's the determining factor as to whether this thing slides or not. Obviously, the more friction, the more vertical I could put this before it slides, right? So how rough is the block? How rough is the surface? That's the question, okay? That kind of tells us the answer. And if you know friction and coefficients, you know if that's slippery or if it's rough, okay? Kind of in between. Anyway, free body diagram, and we'll just put it on the same picture. What do I know about the forces on this thing? From the center of mass, there is, Fg, which is mg. That's always straight down towards the center of Earth, if this is on Earth, which we assume it is. Okay? We have a normal force. What direction is that in? Is that straight up? The normal force is always perpendicular to the surface. Okay, we're okay for perpendicular, that symbol? Okay, so the question is, what's the acceleration? If there's acceleration at all. So what is causing this thing to slide down? The weight is. But it's not just the weight as you look at it. We need to actually break this thing into its components. So for weight, there is a component that is perpendicular to the surface. That is the component that tells you how much is resting on the surface. Okay? In other words, that's exactly opposite to our normal force, right? Let's take this to the extreme. If 20 degrees became 90, then what's my normal force? Yeah, like is it sitting on the surface anymore? Doesn't make any sense, does it? It's free falling. So this component depends on this angle. And then we also have this component. What? All right. So Fg straight down. What is this angle here? Good guess. It is. I'm not here to prove it with math, but this is a similar triangle to the big one, isn't it? Okay? Here's your right angle over there. This component is parallel to the surface, and it better look like that in your diagram. This one is perpendicular to the surface, just like Fn. So that's kind of a little bit in my way. I'm going to huck it over there. So what is causing this thing to go down and slide down this slope? Do you see the force component that's in the same direction as this thing will go? Yeah, that's what's causing the motion. There is friction here that opposes the motion, so I want to put that there. Okay, and again, here's my formula. Force of friction is mu Fn. Mu I know is 0.2. So again, I guess I'll look in the parallel direction first. If this arrow is bigger than this arrow, it will slide. And if it's not, it won't. Is there anything else going on in the horizontal direction? And when I say horizontal, I mean in the same direction as the slope, because technically it's not horizontal. No. So in the parallel direction, okay, call it horizontal if you want, I just did. Let's say parallel. Parallel to the slope, what is this component? If this is 20, this is opposite to 20, so which ratio has an opposite, sine or cosine? Sine of 20 is opposite over, this is mg here, right? So that is fg sine theta. So this one, that's the adjacent side, that is fg cosine theta. So in the parallel direction, that minus that is the net force, which is ma. Okay, that's what's going to cause the motion if it slides down the slope. And then I'll write the other equation. What's happening perpendicular? Is this thing moving perpendicular to the surface? We assume it's not, which means this must be equal to that. Okay? So Fg cosine theta equals Fn. So make the page bigger. How do I solve for this thing? Fg, I know, is mg. So I got mg sine theta minus force of friction is mu Fn is ma. I know the mass here. Okay, it's 5. I know g. I know the angle's 20. I know mu, 0.2. Okay, Fn is right there. I can solve that thing for Fn. So you can do that. You'll probably do that and get a number, but I'll just substitute that in there. Fn is mg cosine theta. Is anybody looking at this saying there's things that could cancel out? Yeah, they could, right? But at this point, I'm not going to do that. And I'm kind of doing this one halfway off the top of my head and halfway checking my notes. So. Okay, m, well, I should have put that in there too. Those are all numbers. M is 5, G is 9.8, cosine of 20, M is 5, and I only got one variable in there, don't I? So that's about as long as I could possibly have my equation. I could cancel everything and divide it by 5, okay? I could have done that. Hope you see that. I could factor some things out if I wanted to. I just didn't. Minus 0.2 times 5 times 9.8 times cosine 20. So all that stuff is 40.7. 35, let's say, is 5a. Divide by 5. And what is A? 8.14. Which is not what I got. When you did this? Oh. Okay, what's going on? FG is mg cosine theta, mu Fn, mu mg cosine theta. Nine degrees? No. I did tell you the story about the girl who was in radians and did her test and got like 18%. Yeah. Oh my. Okay. Oh, there we go. 7.55. Divide that by 5, and that should give me 1.5. That's better. Okay. So, a couple formulas going on, right? Every problem, you should just analyze it like that. X direction, and then analyze it in the Y direction. Okay? And that'll get us what we're getting asked for. Sometimes mass will cancel, so don't freak out. Maybe they won't even give it in the question. That means you probably don't need it. It will cancel. Okay, taken to the extreme, again, it's helpful to vision this. What happens if this angle is 0? If I completely flatten that, then what is the normal component? FG cosine of 0. What's cosine of 0? It's 1. So that's just FG. Is that what we'd expect? Yeah. Right? Okay, so it's maybe helpful to take the extremes if you don't feel like memorizing that or writing it out each time. Okay? And make sure your calculators